All right, in this video, we are going to take a look at some 3D concepts. Now, 3D by definition means three dimensions, and that means that we have the usual, what we see, the X dimension, which is left to right, the Y dimension, which is up and down. But the thing that really makes 3D 3D is the Z dimension, which is depth. And so if we were to look at that, we would be looking forward into the positive Z direction, which is depth, and behind our head would be the negative Z. To our right would be positive X, which is the horizontal axis. To the left is negative, and of course, positive Y is above our head and negative Y is below it. So when we think about 3D, then it's important to understand that that Z dimension is really critical. We also can rotate things in 3D. We can rotate things along the x-axis, along the y-axis, and along the z-axis. You'll see in some situations where that z-axis has been switched to the vertical, to the up and down, and y has been switched to the horizontal. I've never been able to figure out why that has happened or why it happens occasionally, but in terms of the typical XYZ coordinates, Z would be your depth. So one of the things we do when we're in 3D is we think about shapes, and instead of drawing them as if they're flat, we actually create the shape as a 3D object. And in 3D, one of the things we're concerned about is what they call polygon count. Polygons are how many facets or surfaces it takes to build a shape. And as this number goes up, the complexity of the model goes up, and it ripples down through things like rendering times and ray tracing times and a lot of other things. So what we do, instead of creating very complex faceted elements, computers understand concepts of what we call primitives. So the four primitives that we see here are the cube, the sphere, the cone, and the cylinder. And you can build a lot of things out of primitives and thereby save your computer a lot of extra time. As well, there's a concept that we use to save polygons, and it's called extrusion. And basically, an extrusion creates an outline of a shape, and then that outline becomes like a mold, like a cookie cutter, and then you push, literally you push the material through the cookie cutter and you create depth to that model. You'll see in SketchUp, that's a very common way of building models. So when you're working through the tutorials, the very first thing you do is extrude a lot of things. Okay. Another way you build models is what's known as a lathe object. A lathe object is essentially a perimeter, or in this case it would be sort of like that bell shape, and that perimeter is then put on an axis which runs through the vertical, through the z-axis, the y-axis, and then that perimeter is spun around the axis to create lathe objects, things like wine glasses, table legs that are like, if you think about wooden table legs, how they're round and they have, a perimeter, a profile. That's all done with lathing. Lathing is not an easy task to do in SketchUp, but I do have a tutorial posted on how to do it if you're feeling energetic and a little bit exploratory. Here's an example of a shape of a model that's been created exclusively by primitives, right? We've got cylinders, we've got cones, and we have rectangles and extruded objects. As well, things like these windows and the doors are easily done in SketchUp by creating the shape and then just pushing it through until it goes all the way through the object. And so it's pretty easy to do this kind of thing in SketchUp. So obviously we can take a 3D model and really go to town on it. And when you think about building something in 3D, You want to think about it as if you're actually building the object in the real world. If you wanted to make a table, for example, you'd make four cylinders, and you'd get a a cube, and you'd flatten it and expand it and so on to make that tabletop, and then you would attach the legs to the table just like you would in real life. And so when we look at something like this model here, we see things like railings. Those are all built just like a real railing. They're little tubes, and they're all bent around, and then there's little tubes for the supports, and these are basically rectangles that have been adapted to accommodate the pitch of the roof and so on. But it's all built just like a real house. This is a good example of how that looks. If we were actually going to build this in SketchUp, for example, you might create the perimeter of the house and extrude it. That'd be one way of doing it. Another way would be to simply create all of the different shapes, like this little wall right here might be one shape that's extruded slightly. You might make a square and then extrude that, and then take a square and cut it out. You'll see in SketchUp, it's really easy to knock shapes away. So if you wanted to make a sort of that sort of exaggerated L shape, you wouldn't necessarily have to make the L. You'd just make a square and then extrude it, and then you would take another extrusion and you just punch it in there, and it would delete it. So there's some neat techniques that you can use to expedite your modeling process. Every one of these little shelves is essentially built just like you see it. It's got a side, it's got little shelves, and those are all individual parts. But the neat thing is you can duplicate things. So once you've got one side of it and you have one shelf, you can duplicate all the shelves, you can duplicate the side, slide it over, and bingo, you're done. So there's a lot of ways you can think about making your model more efficient. Now, granted, we're not going to get into anything this complicated, but I did want to show you some of the things that are being done in 3D in a simple way. Obviously, if you've seen any movies in the past 20 years, computer generated scenes are the norm now. It's rare to actually have real sets. They're all computer generated, and the actors are shot against blue or green screens, and then superimposed and composited onto the model video. So here's a good example of a situation where there's a very complex surface on these towers. You would never think about modeling that in a 3D model. What you would do is you'd make a very simple, extrusion, and then you'd get a photograph of the element or the facade of the building that you wanted to put on it, and then you would map it onto that surface. This was what's called texture mapping. A lot of people who get started in 3D, they're all Photoshop jockeys, and they just make textures, and then the modelers apply the textures to the model. So it's an easy way of creating very complex environments. Now, it doesn't work up close. In other words, if I were to zoom in on this, we'd see that it's not really a 3D model, but from the distance, the effect is totally believable. Here's something we're not going to get into at all, but I wanted to just show you some of the things that are going on when you model a complex shape like a face or a figure, and you can see, in any of the movies, Cars, all of the Pixar stuff, that's all done with very complex modeling. So it's usually started with a very basic shape, and then you take it into a program that supports a modeling technique called NURBS. NURBS are essentially what's known as non-rational uniform B-splines. I'm not going to get into how they work, but it allows you to push and pull surfaces in a variety of different ways. So you can create, smooth shapes and, eyeballs and so on. And, you could pull out the shoulders and make things soft. And this is what the polygons look like as you're beginning to pull. So the modeler can actually see, how the polygons are being stretched or condensed based on what the NURBS are doing. And they control NURBS almost like a paintbrush. And so then once the model is done, the smoothing is applied, and then you see your model. And then after that, it goes into coloring and texturing and so on. And that's a whole nother step of the game. But this shows you how that model is built. Here's a good example of how a full-blown model has been created. Again, it starts out with something like this, and then after the nerves are applied, and this is where the artistry comes in, making the belly look right, making the jacket flow properly, all these different things. These are all part of the modeling process, and a good modeler is worth his weight in gold. It's a hard job. It may be one of the hardest jobs. And then in order to make it work, I don't have any pictures of this, but there's a thing called, I'm going to pause this because I can't remember the name. Once we get to the idea of the model being done, we animate it using a technique called motion capture. Motion capture essentially takes a person and puts, sensor dots on different parts of the body, depending on the kind of detail. And then that person does some kind of action like walking or something like that. And once that motion capture data is captured, that data is then fed through a program called Motion Builder, and it essentially assigns the dots to a model, and the data from what's captured on the motion capture software then animates the model. Now, the model has to be articulated, it has to have joints and so on, but it really saves a lot of time, where in the past the model had to actually be animated using inverse and forward kinematics, and the animator had to think about every movement. Motion capture really moves that along. Here's an example of, a motion capture headset that also has motion capture data points on the face. And you can see that, let me get to this here. There's a situation here where the motion capture, I wanted to show you some things with the faces. And here's a good example of what happens with the model as the motion capture is applied to the model that's been superimposed. Here's an example where the actress has the capture data all over her face, and then that is applied to the model, and the model then does what the girl is doing. So it's pretty cool. And let's see, we saw that. I wanted to see something else. So here's a good example, of the motion capture, again, being applied to a very different kind of model. But that's what's going on in motion capture right now. And then, and so that's kind of the state of the art at the moment. We're, however, going to step back a little bit, and we're simply going to look at extruding some text and animating it. Okay, so this is the kind of thing that we're going to be shooting for. Okay, so those are some 3D concepts that I'd like you to think about. Just kind of gives you the overall view of the animation and modeling environment.